Does Canada have a problem? Well, not yet on the ground, but the volcano responsible for one of the most violent eruptions in 2023 has entered another dangerous explosive phase. And the concern is not only the ash cloud that it's spitting up high in the air, and it's already crossing the North Pacific. The deeper concern is something else. It is what may be happening to the lava dome at the Shiveluch volcano. This volcano, guys, I have to tell you this is really important. It does not simply erupt from like an open crater as you think, if you imagine a volcano and it erupts and then it calms down. So it has magma, very thick magma that is piling up over the vent of the volcano. And that, of course, you can imagine, that creates a steep, fractured dome that is filled like a lake with extremely hot rock, magma, and volcanic gas. So a dangerous mixture only being held by this fragile cone. So when that structure becomes unstable, part of the mountain can suddenly collapse. And that's dangerous, highly dangerous, because that can release the pressure beneath it almost instantly, drive an enormous explosion upwards, and send pyroclastic flows, explosive volcanic explosions that you cannot outrun racing across the ground. And they can race far. In 2023, it has demonstrated that. That is exactly what happened. So most of Shiveluch's previous lava dome complex was destroyed in 2023. So now a new crater, approximately 1 kilometer or like 0.6 miles wide, was left behind. And imagine, if we have these pyroclastic flows, they can travel more than 20 kilometers, that's roughly 12 miles, and they can burn and bury everything in their path. That's why Campi Flegrei in Naples, Italy, that I report a lot about, the supervolcano Campi Flegrei, people live directly on it because it doesn't have a massive cone like Vesuvius, so people didn't know that. But if that has a pyroclastic explosion, that will already be a maximum disaster. It doesn't even need a magmatic explosion. So here, what we're dealing with Shiveluch, the most powerful explosion may have sent ash as high as 15.8 kilometers, 52,000 feet. So that eruption did not begin with one obvious sign, basically announcing that the entire dome was about to fail. It developed through continuous dome growth. More material was coming out and it was building and it was building and it was building. Then it had some explosions, it had intense heat and some repeated collapses, and it was building up again. And now it is producing, Shiveluch is producing these more powerful eruptions again, these explosions, powerful explosions. So the latest eruption blasted material approximately 39,000 feet. That's 11.9 kilometers up in the air. That's what it's doing right now. So forecasts place the top of the eruption cloud that has come out of there near 40,000 feet. That is really, really high. That is 12.2 kilometers. But I want to make this clear that this was not like an isolated explosion that was following a quiet month. So quiet, and then oopsie. No, just a few days ago, July 2nd, another eruption has sent volcanic material approximately 11 kilometers up into the air, 36,100 feet. Isn't it great that through this, we're learning all these conversions between kilometers and feet and miles? At least I hope we do. On July 5th, another blast reached 12 kilometers, 39,400 feet. July 9th, another explosion, approximately 10 kilometers, 32,800 feet. And now on July 20th, Shiveluch has again produced an eruption that is approaching also 12 kilometers in height. So powerful explosions are basically returning every few days in this month especially. So what does that tell us? Well, guys, I have to tell you that means that the pressure is basically repeatedly building and being released somewhere in there, somewhere inside, and we have to name it an actively changing volcanic system. So, of course, the question that matters the most for us right now is whether these explosions are safely relieving that pressure and nothing else happens, or are they gradually weakening the dome above it? That is the crucial question. And Shiveluch's magma is extremely viscous, so it is too thick to drain easily away from the vent. It's like gluey. So instead, because of that, it rises slowly and accumulates as solidifying lava. So that, of course, you can imagine that this creates a large mass of unstable material that is building up there. So that's not only that. Then we have the fresh magma that continues to push up from below. So if we look at the outside of Shiveluch's dome, it can look quite solid, but what's going on at the same time inside, in the interior, it's intensely hot and gas rich, a dangerous explosive mixture, and we see cracks opening in the dome. We see blocks are breaking away, right? We see hot avalanches that descend down the slopes. So yeah, smaller collapses can generate explosions and ash clouds without destroying the whole dome. This is what has been happening right now. But each collapse that is happening can also change the shape of the structure and the stability of the structure. And basically it can remove support from the material that is higher up in the cone. So let's say if a major section fails from the Shiveluch cone, the sudden loss of pressure can basically fragment the magma underneath it. So what is the result from that? So the result, unfortunately, is not simply a larger version of like an ordinary eruption. No, it can become a violent decompression event. This is what this is called. And it's then combined with a massive landslide of volcanic material. So basically, the falling dome transforms into a pyroclastic flow that contains ash, rock fragments, hot gas, enough to ignite vegetation, and these volcanic rock fragments, they shoot out there like bullets, really, really dangerous, has cost people their lives at other volcanoes in Italy, for example, but also we always see people run from exploding volcanoes. I've shown you all these videos in earlier videos. So that is clear. These flows can move at highway speeds or faster, or German Autobahn speed, let's say it that way. People near the volcano may have almost no time to react. You cannot outrun that. So Shiveluch has now experienced repeated cycles of dome construction and destruction. So, and at least 60 large eruptions have been identified during the last 10,000 years. So this thing is active and it is actually doing what we are afraid of. It's doing it. So major dome collapses have produced debris avalanches that were covering large sections of the volcanoes. It's like an open caldera area. So this is built into the volcano's behavior. It just does that. So this thing can have on the volcanic explosivity index can produce stuff VEI 6 to 7, 5, 6, 7. This is what this thing can do. This is how massive this is. So basically what this volcano is doing, that volcano is growing something that eventually it's not able to support anymore. And that's why, if we look at the eruption height alone and the ash clouds and everything, it doesn't tell us the whole story, what's really going on with that mountain. If we have like a 12 kilometer or a 7.5 mile eruption column, it proves that yes, a powerful explosive event has occurred, but it absolutely does not reveal how much of the dome has moved or become more unstable. It does not show whether new magma is rising more rapidly. We can see it. And definitely it cannot confirm whether fractures inside the structure are expanding and building towards a catastrophic dome collapse. And the weather around Shiveluch is making that uncertainty worse. So especially for the current eruption, when the first aviation message now was issued at 9:20, the eruption was described only as possible because we had thick clouds that were basically hiding the summit. So they weren't really sure. So roughly 2 hours later, thankfully, the Himawari 9 satellite imagery clearly showed that there was volcanic material continuously moving away from Shiveluch. So an eruption had been confirmed by these images. But, you know, if we have satellites that are looking down on the volcanoes through layers of clouds, yes, they can track the spreading cloud, the eruption cloud, right, more easily. But it's hard to reveal every structural change that is occurring in the dome itself. So unfortunately, that leaves an important information gap that we don't have here, right? The scientists can see the result of the explosion basically moving away from the source. And now we have a cyclone approaching. So there's no evidence that the cyclone caused the eruption. I want to make that clear. But the danger is what the storm can do after the volcano has already exploded. Think about strong winds. So if strong winds come into the mix, they can move the eruption cloud rapidly across the Pacific. So thick weather clouds can also hide the continuing activity of the volcano. Heavy rainfall comes with these storms, can strike slopes on the steep hills that are already covered with loose ash, broken lava, and pyroclastic debris. Then we're talking lahars, volcanic, rapid, fast-moving landslides. So if water combines with volcanic material, that is what we call lahars, like fast-moving rivers of mud and ash that follow valleys that are far away from the volcano. I just made a video about Mount Rainier in the state of Washington, where it's a densely populated area and they don't have much time to run away from that volcano, from that lahar. It doesn't even need an eruption. I'll put that in the end screen because it's very interesting. You know, you should check that out. So a lahar does not need a major explosion to begin with. It needs loose volcanic debris that is around the slopes of the volcano, check mark here, steep terrain, check mark, and enough water. It's coming, right? So yes, that threat is mainly local to Kamchatka, right? We just had a megathrust earthquake there last year, but it shows why the volcano and cyclone cannot be treated as like two completely separate events. So one is producing the unstable material, the other can mobilize it. So the greatest immediate threat right now remains close to Shiveluch, but this volcano has demonstrated that it can create eruptions that have large impacts thousands of miles away. And that brings the danger back to Canada and Alaska, of course. The July 20th eruption cloud was moving east and southeast at approximately 148 kilometers per hour. That's roughly 92 miles. And the leading section in the afternoon was already hundreds kilometers east-southeast of the volcano, hundreds of miles. Very, very fast. So the cloud was moving away actually from the Tokyo aviation monitoring region and towards the area that is monitored from Anchorage in Alaska. So that does not mean that British Columbia is about to receive dangerous ashfall. I really hope not. They are already, there's wildfire smoke and stuff like that already. So ash covering the ground, hopefully not, but definitely Canada's first problem would be in the air and not on the ground. But even that has happened before. During the April 2023 eruption, material from Shiveluch crossed the North Pacific and has eventually reached the west coast of Canada. So some Canadian carriers changed routes for flights that were leaving Vancouver and traveling east. So Transport Canada monitored the situation together with NAV Canada and the Montreal Volcanic Ash Advisory Center. So thankfully, then the effects from the 2023 eruption within Canada remained limited, but we have the proof that Shiveluch can interfere with Canadian Vancouver airspace from the other side of the Pacific, and Vancouver is a big airport. Let's not forget that. We're not talking about a local municipality airport or something like that, right? And volcanic ash, if you have that at your flying cruising altitude, that is not the same ash like wildfire smoke, right? It's dangerous because it's not soft ash like wildfire smoke. It has basically microscopic pieces of rock and volcanic glass, and you don't want to get that into your engine. And the problem is also aircraft weather radar has sometimes problems to clearly identify that, to give airplanes the proper warning. Also, pilots may not see it at night, or if it's hiding inside ordinary clouds. And if enough of that ash enters a jet engine, the particles can melt in that extreme heat of the burning jet engine and then attach themselves to internal components of the engine. And then the engine can lose power. Cockpit windows can be damaged, by the way. So sensors, ventilation systems can become contaminated. This is why the aircraft are redirected around volcanic clouds rather than being allowed to fly through them. Today's ash cloud is not yet the most dangerous possible scenario. If the current eruption has ended, the material that's already in the atmosphere may continue spreading and gradually, of course, then becomes less concentrated when it reaches the ocean. The more serious possibility would be another powerful explosion that would enter the same eastward wind corridor before the first cloud has fully dispersed. That would basically feed continuous volcanic material into North Pacific flight routes. So if we have a larger eruption that lasts for several hours, we could have a way bigger affected contaminated area. And if we had a major dome collapse like 2023, that could inject far more material much higher into the atmosphere. That is the threshold that has not yet been crossed here. There's currently no confirmation that the active dome has suffered another catastrophic failure. There is no warning in place that it's heading towards British Columbia and Canada. And there is no proof that it's about to repeat what it did in 2023. But there's also no reason to dismiss what is happening right now. Don't dismiss it as, it's just a minor ash event, right? This volcano has repeatedly generated high altitude explosions, and that cyclone is approaching terrain that is covered with loose volcanic debris. So I will keep you updated. Check out the video on the end screen. You won't believe your eyes and your ears what you hear there. See you there in a second. Stay safe. Bye-bye.